This is revision for OCR Gateway, and we're looking at the first part of P1A here, and we will be dealing with thermograms, temperature and heat. So we'll begin with thermograms. A thermogram is another name for a thermal image or an infrared image, you may have heard it referred to as. And it was taken with a camera that, instead of being sensitive to light, is sensitive to heat. Thermograms use colour to represent the temperature of an object, with whites and reds being the hottest areas and blacks and kind of violets being, and blue and violet being the cooler areas. So you can see on this elephant, actually this part of his trunk is the warmest area, and the background, where there's an absence of heat, there is much cooler. I'm going to talk next about heat and temperature, what each one is and the difference between them. We'll start off with heat. Heat is actually a type of energy, and it's measured in joules, or J for short. Excuse my writing. The direction of heat travel is always to cold. One thing that affects how quickly an object like a cup of tea cools is the difference in temperature between that object and the surroundings. Now, if the surroundings are a lot cooler than the object will cool quickly. So in this example, we've got a cup of tea, and our cup of tea in very low temperatures is going to cool very quickly. Whereas in this example, we've got the same cup of tea on a much warmer day, and the tea is going to cool much more slowly because the difference in temperature between it and its surroundings is much smaller. Okay, we've got here a graph of temperature against time. One of the things that this type of graph tells us is the rate at which something cools down, or it could be the rate at which something heats up. Now, you might be asked to interpret a graph like this, or you might be asked to add another curve to it to represent the information that you've been given in a question. The thing we need to think about when we're looking at a graph like this is how steep is the curve. Let's imagine we've got our cup of tea again, and we're thinking about how quickly it cools. Well, this blue line here shows something cooling very quickly. So this could be our cup of tea on a cold day. The orange line, which is much less steep, shows something which is cooling more slowly. So that could be our cup of tea on a warm day. And the green line in the middle there, something in between. We can take from this that the steeper the gradient of the line, or the steeper the line, the faster something cools. The same is true when the temperature of an object is rising. So let's say we have two objects with the same start temperature and the same end temperature. We have two lines here to show how their temperature changes over time. We can see that this one reaches its maximum temperature more quickly because it has a steeper gradient. So again, the steeper the gradient, the faster something heats up, or the steeper the gradient, the faster something is cooling down. We're going to think now about the difference between heat and temperature. And to do that, we've got a couple of questions about these two images here. So we've got a picture of the North Sea and a picture of a sparkler. Well, the first question, which is hottest? Well, the answer to that is the sparkler. The sparkler is hotter because it's at a much higher temperature. Our second question is which contains more heat energy. Now, the answer to this is actually the North Sea. Despite being at a much lower temperature than the sparkler, so being much cooler than the sparkler, the North Sea actually contains more heat energy overall. The reason for this is to do with the number of atoms each contains. Each atom in the sparkler contains more energy than each atom in the North Sea. However, there are fewer atoms in the sparkler, so overall the total amount of energy contained is less than that in the sea. This gives us the idea that actually heat energy and temperature are two very different things. Okay, this next piece is only relevant if you're studying for the higher tier. Well, we know that heat is a type of energy and that it's measured in joules. We can also add something now about temperature. Temperature tells us how hot something is, so we can say that it's a measure of hotness. We choose the scale that we use to measure temperature, and at GCSE that will always be degrees Celsius. There are, of course, other scales. Fahrenheit is one you may have heard of, and if you go on to study A-level, you will also use Kelvin. Now, the hotter something is, the more the particles that make up that object will start to vibrate, and the more kinetic energy they will have. So actually, temperature is directly linked, it's directly proportional to kinetic energy. So a more detailed definition for temperature would be to say that it's a measure of the average kinetic energy of the particles of an object. I'll just write that here. So I'll say that again. So the temperature tells us the average kinetic energy of the particles, and it's a measure of the average kinetic energy. And that's all for this section.